I have been working as a programmer for 6 to 7 years now, and I must admit that I was not really good at it for long periods of time. And there are many factors for this. I simply wasn't that much interested in it. I loved screenwriting, I loved something else, I loved teaching basically. So, if you are like me, somebody who is not that much passionate about programming or, about computers in general, and still you want to become good at this, do better in your jobs, do better in your academics, I would like to share with you an approach that I have developed over the years, which has helped me to get better at programming. One of the most fundamental things in order to become a good programmer is to keep learning new things, new technologies, new programming languages, new concepts, new paradigms. A lot of people struggle with that. People do not want to learn new things because they are content with what they know, or they are afraid that they are not capable of learning new things, or they are not interested. The WWH attitude. Trust me, and trust me really well on this, that if you develop this what, why, and how attitude, it will help you enormously in your programming career. You can basically work in any goddamn software company in the world and compete with best of the best programmers if you develop this what, why, and how attitude. So this begins with a question, a simple question, that is what. Maybe you're looking for a job, and the job descriptions have these keywords such as agile development or big data or React.js, right? And you don't know what these things are. Or you have joined a new company and this new project that you are supposed to work on requires you to work on AngularJS, but you don't know what AngularJS is. No matter with the reason, if you do not know something, instead of ignoring that thing, instead of saying that, I don't need it, who cares, you should ask what. What is it? Like, what is React.js? What is HTTPS? What is big data? If you are not asking enough what's, maybe then you're not cut out to be a good programmer. 2 months back, I was searching for jobs, and a lot of those job descriptions had this requirement React.js or AngularJS. And till this point, I came from Ruby on Rails development background, so I had never used any front end framework. So I had no idea what React is or what Angular is, right? But as soon as I realized that I don't know, the simple question came to my mind: what is React.js? Right? Now look at this answer for React. It's a JavaScript library for developing single page web application. But if you're not aware of these terms, probably this answer can give you more set of what's. For example, what is JavaScript? What is open source? Or what is a library? Or then what is single page applications? In order to answer your first what, if your mind asks few more what's, that's good, that's really good. That means you are on the path of becoming a better developer. Ask what till the time you do not understand what you're trying to understand. Creating the need in your mind of knowing something is the start of this process. Once you have asked all these what's, right, and you know what these things are, now you're ready to move on to the next part, which is the why part. As important it is to ask what, more important is to ask why. Asking why will create the necessary momentum, the necessary drive for you to go on and learn that technology or that concept. For example, you are learning a new technology. You know what that technology is. Now you could say, why is this technology used? Or why do I need to learn or to use this technology? So these are two examples of why. But you can definitely create your own set of why. You need to justify to yourself why you are learning this thing. Again, let's take example of React and HTTPS. So why is React.js used? It enhances the performance of web applications. You can create desktop-like feel on your web applications using React.js. It reduces the DOM manipulations. Now I'm going a little bit more technical, But the important thing here is asking this why will give you enough motivation to learn this thing better. This is also very important. Why do you need to learn? Probably it will help you find employment. Probably it will make your job easier in your next project. Probably this is the best technology for your startup idea. So you need to know that, right? Now, once you have the information through what and motivation through why, you're now ready for the last part of this approach, that is the how part. How does this technology work? How does React work? You can go into the fine details of the React JS technology and understand how can I start practicing this technology or using this technology? How can I use this technology in my current work? The most important, according to me, is how can I become good or better or best, if you want, at this particular technology? How part could also be sometimes optional. For example, you learned what is HTTPS, right? It's secure HTTP. Then you learned why it is used. It is used to secure the critical financial data when it is passed over internet. Okay. Now, probably you are still in your college and you don't need to use HTTPS right now because the website that you are building does not have any critical or sensitive data, right? So in that case, you can skip this how part for now. You can say, okay, right now I don't need to use HTTPS or I don't need to install HTTPS certificate for my website. Cool, you can skip this part and probably few years later when you're working on any such project which needs to use HTTPS protocol, that time you can learn how to install HTTPS certificate and use that protocol for your website. So what and why are a must, how can be optional at times, but I would still say that ask how and get to know how. The second point in my 4 point mantra for becoming a better programmer is this technique of divide and simplify. No matter how big the project is, no matter how complex the assignment sounds, what we can always do is we can break down that problem or that project into set of smaller tasks. And trust me, these smaller tasks are much more easier to solve, right? And as you go on solving these smaller tasks, even before you know it, the big solution starts forming in your mind, in your head, and eventually you will be able to solve this big problem which you thought you could never solve at the beginning. I know this sounds like a cliche, but trust me, it really, really works. So let's take this a little bit complex program of how to reverse a doubly linked list. So this is my doubly linked list, right? With 5 nodes, and each node stores a single integer as part of its data element. So this is the data part, and as you might know, this is the previous pointer and this is the next pointer. So I hope you know the basics of doubly linked list, right? This is set to null. The previous pointer of first node is null, and the next pointer of last node is also null, right? Now we need to reverse this linked list. Instead of trying to solve the entire problem at once, I'm gonna think about how can I divide this task, right? I can see there are two options. So one approach would be to start breaking down these links and start attaching nodes in a reverse direction, right? So that this becomes my last node and this becomes my first node, right? So I'm going to break the links, I'm going to move the nodes so that 10 becomes this becomes the first node, then I'll attach this here, I'll attach this here, I'll attach something like that. Or as I see this problem, this particular problem, the data part is only one integer. Each node is storing only one integer as data. So probably I could reverse this entire linked list just by swapping the data. So basically, if I can make sure that I swap 5 with 10, so and then I can swap this node, and I don't even need to swap this, and without moving the nodes, I can reverse the linked list. So that becomes my second approach, swapping data. I've decided to go with swapping of data because that seems like a more optimal solution in this case because the data part is only one integer. Okay, so next point is how to swap the data. So to swap the data, I'm gonna need one pointer P which starts here, right? And then I'm gonna need one pointer here Q which points to the last node. So my next smaller task will be how to get Q from head, right? Head is the pointer which represents the first node always, right? I hope you know this convention in linked list. So head to last node. And to achieve this, the code is pretty simple. Initially you will start Q here, P equal to Q equal to head, right? So both of them, P and Q pointers will be at pointing to the first node. And then you need to take this Q pointer to the last node. So you can say something like while Q arrow next not equal to null, right? Because we know that the last node's next part is going to be null. So we can say while this is happening, Q equal to Q arrow next. Just keep on increment Q, pointing Q to the next node. And as you iterate through this loop, by the time Q reaches here, right, Q arrow next will be null, hence this condition will fail and will stop the loop by the time Q is here, so it is pointing to the last node. So we solve this small task of how to get Q from head to the last node. Now the next task is to actually swap the data. Now the swapping of data is pretty easy, right? You know the code, you take another variable, integer, temp, right? So you're basically swapping the value of 5 with 10, 5, right? Now, in order to further reverse the linked list, we need to move the pointers. So we'll just say P equal to P arrow next. So P goes from here to here. And then we say Q equal to Q arrow previous. So we need to move Q backwards. So Q moves from here to here, right? So that's where Q goes. Again, we need to swap. So we can repeat this whole code. So basically, we need to put this entire code in some kind of loop. When it comes to writing a loop for this, in this case, when there are 5 number of nodes, if P next time we swap 15 and 30, P will get here, right? P equal to P arrow next. And Q will get here, right? You can write a condition such as P not equal to Q, right? As soon as they become same, P comes here, Q comes here, we can stop. We don't need to swap this. And that's it. We increment P, decrement Q, both come here. We don't need to swap because P not equal to Q is false now. And we can just stop and we have our linked list reverse, right? But this will be short-sighted. So in this case, these are odd number of nodes, 5. But if this was a linked list with even number of nodes, then we had a problem, right? This is a linked list with 4 nodes. So P starts here, Q starts here. We swap the values. P not equal to Q. We say P arrow next comes here. Q comes here. We again swap the value. Now we say P equal to P arrow next. So P goes here. So they basically cross. So P comes here and Q goes here, right? Now P not equal to Q. So our loop will keep on executing, right? And will basically run, I guess, into infinite loop situation. So this logic works for odd number of nodes, P not equal to Q loop condition, but not for even number of nodes. So in even number of nodes, I'll have to write some other logic. The second logic is P arrow previous not equal to Q. So once they cross, right? Once P goes here and Q goes here, we must stop because as soon as they cross. So we need to check for the condition P arrow previous. So P is here. So P arrow previous not equal to Q. Right now when they cross, P arrow previous becomes Q, right? Once they cross. And we need to stop here. So when P arrow previous not equal to Q, this takes care of our even number of nodes situation. When you combine them using AND operator, our logic of swapping the data and incrementing pointers works for both even number of nodes and odd number of nodes. So this is pretty much the program to reverse a doubly linked list, right? But if you see how we solve the problem, first we determine, do we need to swap the data or swap the nodes? Then we determine how to swap the data. Okay, so we needed two pointers, P and Q, right? We needed P at the first node and Q at the last node. So how to get Q from first position to the last node? Because we always get head, right, in any linked list, the first position, we don't know the last position. So then we wrote a logic to take Q from first to last. Then we had another problem. Now, how actually to swap the data? So we needed to create a loop, but that loop initially only worked for a doubly linked list with odd number of nodes. Then we had to think about what will be the exit condition for the loop in case of even number of nodes, right? So can you see what's happening here? I basically divided this whole problem into set of tasks, one, two, three, four, and I focused on solving that task only. Eventually, when I managed to solve all the tasks, I got my final algorithm. So remember, no matter how difficult the problem or the project looks in the beginning, you can always divide into set of tasks and start solving the task. Eventually, you will get a solution. My next point in our 4 point mantra to become a better programmer is to anticipate change. Nobody is going to pay you high amount of money just to write a software which works for 2 months or 6 months, right? And in order to write durable software in this ever changing era of technology, you need to develop this attitude of anticipating change. Write your code in such a manner that that code or that software will accommodate changes quite easily, right? If you're not writing that kind of code, you are not a good programmer. One very simple example I can give is this very nice principle called as dependency injection principle. So what is dependency injection principle? Code to interface and not to implementation. Okay, this might seem a little bit more technical, but I'll break it down. So let's say if you have a function, let's say ABC, and this function requires you to create a new object of a car. So let's say car equal to new Toyota. So you are creating a object of Toyota class, right? And then you say car dot drive, right? And then something like some other code. Now, what you're basically doing is that you are creating an instance of Toyota car to give you this functionality of driving, right? But this is a very, very rigid code. This code will always and always use Toyota class object to get this drive functionality. What if tomorrow I don't want Toyota? I want, let's say, Ferrari's driving functionality or Mercedes. So this code is not good, in accommodating changes. Create an interface, interface car, and then provide a blank method called as, drive. And now you can just add instance of car C as an argument to this method, and then you can just say C dot drive. Basically, we are saying that this ABC function will require an instance of interface car, right? And then we'll just call the drive method on that instance C. Now, while calling this function ABC, you will have to provide the actual object for this C. So let's say you have a class called as Ferrari, which implements, this interface car. So Ferrari will give a functionality for this drive method, right? With its own logic, the way Ferrari wants to drive, right? So you can pass, while calling this ABC function, you can just pass this Ferrari instance. So let's say new Ferrari, right? Now here you will get output or driving functionality as a Ferrari car. Or you can call this function with object of new Ducati class, and that will give me the drive functionality of a Ducati. So this is basically what dependency injection principle is. Always code to interface and not to implementation. A good analogy of this I would give is the way Uber functions. So Uber provides the functionality of transportation, but they don't own any cars, right? Uber leaves that specific implementation of providing transportation to its partner drivers who will get their own cars. So Uber just defines a standard, an interface, how things will work. But actual implementation is provided by the drivers who also bring their own vehicle to Uber. That way, what Uber can do, Uber can change the way we transport anytime. Tomorrow, you might get Uber rides on two wheelers, on bikes, right? That is already happening in certain countries. Then tomorrow, you might get Uber rides via boats, or horses, or dogs or donkeys. Who knows, right? Because what Uber has done by not tying itself up to specific type of automobile, it has made itself open to change, right? Any change in future in the way of transportation, Uber can accommodate it because Uber is only defining interface, the standard. The specifics of functionality is coming from drivers or the partners of Uber. So that is the way you write code. You follow design patterns such as dependency injection so that your code will easily accommodate the changes that are bound to happen in future in your software. You will be valued so much in your organization if you develop this attitude of anticipating the change. My final point in my 4 point mantra to become better programmer is this attitude of less but more. Recently, I've been taking many interviews for developer position in my organization, and I need to go through this, resumes every day almost, and I see people listing 20, 30 technologies in the resume. It's almost like sometimes a resume says that this guy or this girl is a good database administrator, a good web developer, a good QA, a good big data developer, on and on and on. Say C, C++, C Sharp, Java, PHP, Ruby on Rails, Angular JS, React JS. It's mind boggling how much people write on the resumes. But you know what? That's not going to get you any job. Just by listing shitload of technologies on your resume doesn't make you any good programmer. What is important is that you know fewer technologies but you know them better. So you know less technologies but you know more about them. You all must have used version management system or version control system called as Git. When it comes to Git, usually people know, commits, Git pull, Git push, cloning a repository, and that's pretty much it, right? But do you know there are so many other concepts, so many other functionalities that you can make use of while using Git? For example, there's something called as Git bisect, which can perform a binary search to find out which commit of yours introduced a particular bug in your repository. Then there is something called as cherry picking, Git merging versus Git rebasing. There's something called as staging area, working directory. There's so many concepts, so many useful things in Git that you can leverage while you are developing your project. But do you know all these things? Probably not. So remember this: you don't need to know everything, but whatever you know, you should know it really well. You should be expert of that thing, right? So less but more. That was pretty much it. That was my 4 point mantra in order to become a better programmer. I have learned one thing is that is good programming is as much a discipline as it's a skill. Anybody can become a good programmer if you acquire that discipline, if you acquire that attitude, to learn new things and learn them really well.